Now that we've had a chance to convert parametric equations to rectangular and vice versa, we are now going to take a look at how to graph these equations by hand and also using the calculator as a tool. So before we even get started, why don't we put our calculator in the right mode? So hit mode right next to your second button, and let's go down and make sure we are in PAR for parametric. It might be a little longer than that in the color calculator. And then now that you hit your y equals, you're going to see x and y. So we have those two equations that we will be able to plug in. And in fact, I'm going to plug in my first set of equations. Now when you hit the x button, it gives you a t instead of an x. And there are 4 things on there since we have 4 different graphing modes. And then for now, I'm going to leave that alone and think about what we're then going to need in the calculator to help us with graphing. So what's also given to us is this -1 to 4. So it's giving us an interval that we're going to be graphing this. Remember, t is a parameter. So we could look at that as time, like where it is in a certain time location on your graph. And then also it's showing us motion because of that time. So there's a certain direction that we're going in, which will kind of remind you of something called a vector, if that's something you've already studied in your science classes. So before we do our converting, we're going to get our table set up. We have 3 columns now instead of 2. And that interval is giving us a starting and a stopping point. So we're going to go -1, 0, 1, 2, 3, and 4. And then technically what you're doing is you're plugging in -1 into your x equation. If you do that, 1 minus 2 times -1 is going to give us 3. And then we'll plug the -1 into the y equation. 1 minus 1 is 0. If you want to make that process go a little quicker, now that we have our 2 equations in, if you hit second graph, you can scroll. I happen to be in a perfect spot in my table, but let's say we weren't. Scroll until you get that number, that starting number that you chose or that was chosen for you to be right on the top. So I'm going from -1 to 5 in this case, but I'm going to stop at the 4. And then we can just go in order and copy down our points. So we have 1, 1, -1, 2, -3, 3, -5, 4, and -7, 5. And then the order that you plot them in is also going to give you your direction. So I want to indicate that direction by putting more than 1 arrow on my graph. So I'll start 3, 0, 1, 1. Now this is going backwards of what we might normally do when we put arrows on our graphs, right? We're going to the left. And you can kind of see the slope happening here, so this looks linear. And then there is a point where we stop. So connect these with a line. But somewhere in the middle, put an arrow of the direction that we're going in. In this case, since it's linear, we really only need 1 arrow to show that. I don't want to put it on the end of the graph because this has a clear starting and stopping point based on that interval that we have circled in red. And then that starting and stopping point's actually going to impact our domain and range. So we will convert in a second, but we're going to get a line which technically would go on to infinity in both directions, whereas in this case, if we look at our domain, our furthest left is -7 and our furthest right is 3. So we have 2 ways we can write that. Let's remind ourselves of both ways. I think that's good as we're getting close to the end of a school year to just review both of those options for domain and range. And then we're starting at, I'll just switch colors here, 0 on the y and ending at 5 on the y. So we're going 0 less than or equal to y less than or equal to 5, or 0 to 5 with brackets in that interval notation. Again, that's important for when we do go to convert, since a line would go technically arrows in both directions. We don't want that here because like we stated before, we are starting and stopping at those red dots. All right, so let's practice our converting. I think the easier one to solve for is going to be the y equation. So I'm going to subtract 1 from both sides. I get y minus 1 is equal to t. And then I'm able to plug that in to the t in the other equation. So it'll be x is equal to 1 minus 2 times y minus 1. And then we'll do some distributing and solving. And then since this is linear, we want to solve this for y. So subtract 3, divide by -2 each of our terms. So we end up getting y is equal to -1/2 x plus 3 over 2. And again, with these restrictions on our domain and range, since that normal linear graph would go on forever both directions. Now we're going to get more into this viewing window when we look at some of our applications in this unit, but we have it already graphed in here. I just want you to hit window just to show you what's happening. Now we were given a t minimum and a t maximum. We were given -1 to 4. So I'm going to include that here. And based on the domain and range from our graph, we can use the domain and range that are given. We can keep it -10 to 10. I'm actually going to keep it -10 to 10, just so I can see the way it's showing up on the graph and kind of match it up here. I mean, the graphs that we are on go from -8 to 8, but that doesn't really matter. Scale of 1. If we leave it -10 to 10 now, we don't have to make any changes. And then the only other thing, this is actually going to give us the speed and the accuracy. So I'm going to do 0.1 here. You could do 1. The smaller the value, plots more points. It also makes a more accurate graph. The problem is the smaller you make it, the slower it goes. So there's a warning here that it does give you the speed, which is good and bad. So let's say I put like 0.01 here, and that might be a little slow. So I'm going to hit the on button and stop it. So you can stop your graph and you can edit that window if you decide it's going too slow. And then I'm going to give this a 0.1 instead. So notice, based on this picture compared to the one we drew, it is starting and stopping at those restriction points. It's not graphing that entire line. So hence the importance of doing that. Now on the future ones, we're not going to put a window in. I just wanted to show you and kind of compare that with the calculator. So we'll do one more example in this video and take a pause and then start up again with 2 more examples on our second video. Now I think it's a great idea to still use the calculator for the table aspect. So let's do that. I'll put in, clear that, put in 2t. Clear this one, and you can clear one at a time, which is nice. It won't do anything until you have both equations put in, and then I will go to my table. And this one actually is also starting at -1, so let's set ourselves up here. We're going t, x, and y, -1, 0, 1, and 2. So a couple less points here. Again, we can copy down from our table the -2, 0, 0, -1, 2, 0, and 4, 3. Now remember, this is the direction that we're going in. So really, we're only plotting the points start with -2, 0, then go 0, -1, then 2, 0, then 4, 3. And if you can remember the order that you plotted them in, that's going to help us with direction. So I'm going to put 2 arrows on here, one here and one here in the middle. Maybe I'll highlight them in red a little bit so it's easier to see. Again, notice I'm not putting them on the ends of the graph because the graph itself starts here and stops here. So before I even do my converting, I can see that I'm going from -2 to 4 in my domain. So write those two different options. And then the range, I'm going from -1 is my lowest and 3 is my highest. And then the last thing we're doing is converting. So again, I go with the easier one. I'm going to take the x is equal to 2t, solve for t by dividing. And then we will substitute this into the t here. So y is equal to x over 2 squared on the outside minus 1. And then I'm just going to simplify that a little bit. X squared over 4 minus 1. You can even rewrite it as 1/4 x squared. Either of those options is good. Let's just put an or in there. And you can see that it is a quadratic or a parabola equation, and you can see a portion of a parabola. Obviously, if we were to keep this graph going, it would go this way and this way. But I'm going to undo that because we are only graphing that smaller portion of that parabola graph, again, with these particular restrictions. So take a minute to digest that before starting up on the second video.